So today we're going to do a quick instructional video on how to add or subtract polynomials. So right here we're basically combining like terms. So I see 15m to the third plus 6m to the second plus 2m to the third. We're supposed to combine like terms. So m to the thirds are only allowed to be combined with other m to the thirds. This is not an m to the third, but this is a positive 2m to the third. So I am allowed to combine m to the thirds with m to the thirds. I'm only allowed to combine this 6m to the second with other m to the seconds. I don't see any other m to the second, so I'm not going to color those yellow. So I used my color pencils to help me visualize my m to the thirds and to help me visualize my m to the seconds. So this 15m to the third can be combined with this 2m to the third. And then my yellows, this positive 6m squared, can only be combined with other 6m squareds, but there are none. So I rearranged so my m to the thirds are written together, and I rearranged so my m to the seconds were written together. So now I can go ahead and combine. So if I had 15m to the thirds, and I was going to add that to 2 of my m to the thirds, how many m to the thirds did I have? I actually ended up having 17m to the thirds, and then my m squareds. There were no other m squareds to combine with, so that was still a positive 6m squared. M to the thirds do not get combined with m to the seconds because they're different units. So this is my final answer, and I'm done. This example problem over here is the same. So I have a y to the fifth, so this is a 0.9 y to the fifth. He can only be combined with another y to the fifth. This is a y to the fifth, so this is a negative 0.4 y to the fifth. That is not a y to the fifth, but this is, so this is a positive y to the fifth. I am going to rewrite it so all of these y to the fifth powers are next to each other. This is a positive 0.05 x to the fifth. This x to the fifth can only be combined with other x to the fifths. I don't see any other x to the fifths. So I'm going to rearrange it so I can visually see the y to the fifths all next to each other. And that was a minus 0.4 y to the fifth. That's a positive 1 y to the fifth. And then I have my x's, so 0.05 x to the fifth, and there's nothing else. So I wrote my y to the fifths all together, and then I wrote all my x to the fifths next to each other. So if I had 0.9 y to the fifths, and I took away 0.4 of those y to the fifths, I'm left with 0.5. Add that to one more, I have 1.5 y to the fifth. Now my x to the fifths, there was nobody else to combine them with, so I have plus a 0.5 x to the fifth. Now this is supposed to be in standard form. In standard form, it's supposed to be in alphabetical order. So this x to the fifth should have been written first, and then the y to the fifth should have been written second. So this is my answer, and I'm done. So one more example of combining like terms. This is an x to the second y. So I have an x to the second y. This is also an x to the second y, so that's minusing an x to the second y. This is also an x to the second y, so he's also. So it looks like all of these are all x to the seconds times y, so I can combine all of them. So if I had 2 of them, and I had to take away one of them, I'm left with 1, and now I had to take away another one. So I'm left with, I have 0 x squared y's left over, which meant I actually had 0 left over, and so I have nothing. Over here, x to the 8ths, I need to visually see, here are my x to the 8ths. That is not an x to the 8th, but this is, so here is my minus x to the 8th. No other x to the 8th, so I now identified all my x to the 8ths. I'm going to go and identify my y to the 8th. So this is a positive 7 y to the 8th. And here's another y to the 8th, so this is a minus y to the 8th. I visually identified my x to the 8ths, and I separated them from my y to the 8ths. So alphabetically, my x's go first, so that was my 2x to the 8th, and I have another minus x to the 8th. There are no other x to the 8th, so now I'm going to do the y to the 8th. So that's a plus 7 y to the 8th power, and that's a minus y to the 8th power. So I see that I had 2 x to the 8ths, and I'm going to subtract one of those x to the 8ths, so I'm left with 1 x to the 8th. Now looking at my y to the 8ths, if I had positive 7 of them, and I took away one of them, I was left with a positive 6 of them. Now you can write the 1, you don't have to write the 1, so if you want to simplify it down all the way, you can leave it like that, and then you're done. So in our previous problems, we were just basically combining like terms. Right now, we see that we have a polynomial in a parenthesis, and we're supposed to add it to a second polynomial that's in a second parenthesis. So what you need to remember is that you start with this, so I start with a 2x squared minus x, and then I'm supposed to add everything that is in here. So I'm going to add an x squared. So here's me adding an x squared. And now I'm going to add a positive 3x. And then I'm going to add a negative 1. So there's me adding my negative 1. So now it looks exactly like the combining like terms problems that we have been doing. So here is my x to the second power. He's not an x to the second, so I can't combine it with him. He is also an x to the second power. He is not, neither is he. So I've physically identified my x to the second powers. Now I'm going to go through and identify just my regular x's, my x to the first powers. So this is an x to the first power. This is also an x to the first power. I've identified all my x to the first powers, and I'm going to keep going through and identify every part. This is just a unit. It's a constant. I don't see any x's, no variables or anything. So here's just my constant. I don't have any others. So I have my 2x squared, and that's added to my x squared. So here I identified my blues. So this right here was me identifying my blues, my x squareds. Now identifying my x's, that was a minus x, and that was a plus 3x. So right here is me identifying just my x's. And then I had my just minus 1, my constant, and that was in green. So here's me identifying my green. You know you have simplified your problem all the way down when each color has only one term written in it. This purple currently only has 2 terms, so it's not simplified at all. The yellow also only has 2 terms, so he's not simplified all the way yet either. The green only has 1 term in it, so he is fully simplified. So now we need to continue to simplify the purple and the yellow. So my purple are my x squareds. If I had 2 x squareds and I added another x squared, I'm left with 3x squareds, and that was me simplifying my purple, my x squareds. Now yellow, those are my x's. I have a negative 1x, and I'm going to add 3 x's. So I know I left over as a positive 2 x's, and that was me simplifying down my yellows, my x's. So I'm left with just 1 term, so he's done simplifying. My greens were already all the way simplified. It was just a minus 1. So there's my constant for a minus 1. I have 1 term for purple, 1 term for yellow, and 1 term for green. My x squareds are just 3x squareds. My x's are just 2 x's, and my constants is just a minus 1. So this is fully simplified, and I'm done. So we're going to do another practice problem. I have this entire polynomial, so here is the starting polynomial. And now I'm supposed to add everything that is in the second polynomial, because it tells me to add. So I'm going to add a to ab, and then I'm going to add a positive ab. So now I'm going to go through and I'm going to identify all of my terms. This is a ab term. That's not an ab term. This is a positive 2 ab term. So I've identified all my ab terms. Now this is just a b term. There are no other b terms. And this is just an a term. There are no other a terms. So I've identified 3 different terms. There are my ab's, so I have a negative 2ab, and I'm supposed to add that to a positive 2ab. So those were my purple ab terms. Now I see I have a positive b. There was no other positive b, so I've identified my yellow b terms. And then I see I have added a. That's my green term, and he is my only green term. Remembering each color is supposed to be simplified all the way down to where it has 1 term. So my purple has 2 terms in it. It's not all the way simplified, so I need to continue to simplify it. I have negative 2 ab's, and I'm supposed to add that to 2 more ab's. That ends up giving me 0 ab's, so that is me simplifying down my purple to 1 term. My yellow is already 1 term. It's an added b, so there's my added b. And my green is my term of a, and he's already 1 term, so he's done. Now, in theory, we've simplified every color down to 1 term, but what do I really have if I have 0 ABs? If I have 0 ABs, I don't have anything here. So all I have left is my B plus A, but this is not in alphabetical order. So I need to have it in A plus B, and then I am done. Now, what do you do if it's a subtraction problem? You got to be really careful because people forget that it's subtraction and they just continue to solve it the way we have been doing the adding problems. So you start with the starting polynomial. So I have a 2x squared plus 6, and I'm supposed to subtract everything in the next polynomial. So I'm supposed to subtract this 4x squared. Well, so this is my new problem. Identifying here is a x squared, and I'm going to identify my other x squareds. And I see that I still have parts that need to be identified. He's a unit of a plus 6. Everything's been identified in my problem, so I'm going to combine all my terms. The purples were x squared, so he's a 2x squared, and he was a minus 4x squared, so that is me finding all of my x squared terms. And then I have an added 6. He's a single constant term, and I lost my green, so we're going to do another green. There's my constant term. He is one term, so he is simplified. My purple has 2, so we need to continue to simplify it. So if I had 2x squareds, and I'm supposed to take away 4x squareds, I'm actually left with a negative 2x squareds. That was me simplifying my purple x squared terms down into 1. And then the plus 6, he's a constant, and he is already all by himself, so he's done. My purple only has 1 term in it, my green only has 1 term in it, and they are done. We are going to do a couple more example problems of subtraction because kids struggle with these. So I have my starting polynomial, so here's my starting polynomial. I am supposed to subtract a 3a to the 4th, so there's me subtracting the 3a to the 4th. I am supposed to be subtracting this negative 3a, and here is me subtracting this positive 1. Now I don't like writing it like this. If you're minusing a negative, you're actually adding. So I am going to rewrite it so it shows that I'm actually adding the 3a. And now I want to combine like terms, which means I need to identify. So here's my a to the 4th. Looking for a to the 4th. Here's a minus 3a to the 4th. No other a to the 4th. So taking my next color, this is an a. So I'm going to go through and identify my a's. Here's another a. Identified all my a's. I still see I have other things to identify. Here's my constant of a minus 1. No other constants. So I have my purples, which are a to the 4th. He's a positive a to the 4th, and he was a minus 3 a to the 4th. That was me rewriting and locating my purple a to the 4ths. Now rewriting my green a's, so that was a minus 2a, and he's a plus 3a. That is me rewriting and relocating my green a's. And then here's my constant minus 1. There are no other constants to rearrange them with, so there's my constant. I have 3 different colors, so I should end up with 3 terms. This purple needs to be simplified down to 1. If I had a to the 4th and I subtracted 3a to the 4th, I actually have a negative 2a to the 4th. So that is me simplifying my purple a to the 4ths. Now I need to simplify my greens, my a's. If I had a minus 2a and I added 3a, I actually have a plus 1a. That was me simplifying my green a's. And my unit of a minus 1 had nobody else to simplify, so he is just a minus 1. A to the 4th has no other a to the 4th to combine with. My a has no other a's to combine with. And my constant has no other constants to combine with. So this is my final answer, and I'm done. We have 2 more practice problems to do on subtraction because kids struggle on these. So you start with your first polynomial, and then we are supposed to subtract everything in the second polynomial. So here's my subtraction, and that's an x to the 2nd power. And then I'm supposed to subtract, so here's my subtraction, and we're supposed to subtract that minus 4, the negative 4. I don't like writing a minus negative. It's supposed to be a plus problem, so I'm going to rewrite it so I can visually see that it's actually an added problem. Now that I've actually gone through and I've subtracted, I need to combine like terms. So going through, I see that I have an x squared right here, looking for more x squares. There's another x squared. I'm all out of x squareds. So continuing to identify, that's a minus 2x. There are no other x's. Going through and continuing to identify, here is a whole constant number 8. Here's a whole constant number. Everything in the problem's been identified. So my purple are x to the squared, so we're going to rewrite them so they're all next to each other. So those are my x squareds. My green is a minus 2x. There's me rewriting my x's, so they're all next to each other. And my yellows are my constants, so here is me rewriting those, so they're also all next to each other. So simplifying my purples, my x squareds. If I had 3x squareds and I had to subtract one of those x squareds, I'm left with 2x squareds. That's me simplifying my purple x squareds. My negative 2x is already simplified all the way down, so he's done. My constants, I had a positive 8, and I'm supposed to add 4. So I actually have a constant of a positive 12. My purple is one unit of a 2x squared. There are no other 2x squareds. My green was the units of x, and there are no other x's. And my yellow were the units of constants, and I see there are no constants. So that is my final answer, and I'm done. This is our last example problem for today. We are still having one polynomial and subtracting a second polynomial. So you always start with this one, the first one. So here's me starting with the first polynomial I'm given. And then I'm supposed to subtract an x squared. So here's me subtracting my x squared. And now I'm supposed to subtract my x. So here's me subtracting the x. and now I'm supposed to subtract the 1. So here's me subtracting my 1. Now that I have distributed this negative sign into everything in the second polynomial, so I'm actually subtracting, I'm going to identify so I can combine my like terms. This x squared needs to go with this x squared. Looking for x squareds. Here's another x squared. No other x squareds. So all my x squareds have been identified. Now I see a constant. So here is my one constant. Looking for more constants. Here's a constant. And there's still more parts in there that need to be identified. I see I have an x. No other x's. So everything's been identified. I am going to rewrite it so that I could see all of my green x squareds next to each other so I know that I'm combining them correctly. I'm going to rewrite it so my purple constants are right next to each other so I could see if I'm combining them accurately. And I'm going to combine my x's so I can see if I'm combining those accurately. So if I had 2 x squareds and I subtracted 3 of them, I have a negative 1. Subtract 1 more, I have a negative 2x squareds. Those are my x squareds all combined, so those are my green. If I had a positive 1 and then I subtracted 1, I actually have 0. So that was my 0. That was me simplifying my purple. And then I had a minus x. There was nothing else to combine them with, so there's my minus x. This is not written in standard form. In standard form, you should have the highest power written first, and then you should have the next lowest power, and then the constant. Now, if you're adding 0, you're not really adding anything. So your final answer is a negative 2x squared minus x, and you are done.